We're continuing here on chapter 11, talking about angles of polygons. If you remember yesterday, we talked about the sum of the interior angles of a polygon. And that formula, if you remember, for the sum of interior angles, that is 180 times n minus 2, where n is the number of sides. So now we're going to take that a step further now, and we're going to talk about some exterior angles. So we're going to start off here with the exterior angle theorem. The sum of the measures of the exterior angles of a polygon is 360. So sum, remembers that's our addition. We're looking at the exterior angles, and that will always be 360. It does not matter what polygon you have, whether it's a triangle, whether it's a quadrilateral, whether it's a pentagon, whether it's a decagon, it does not matter. So what we do is we literally take the exterior angles. Here I've represented 5 of them here on the screen. If we take those, we put them together, you'll notice that those 5 angles do indeed make a full circle. Okay, so when we look at that, that's what we're talking about. So if you have an exterior angle, all of the exterior angles add up to 360 degrees. So how do we use this? Well, here we'll notice that we have 4 angles. We have 89, 67, x, and 2x. And we can take those and say 89 plus 67 plus 2x plus x, and that equals 360 degrees. Once we're here, we just simply add those together. So that's going to give us 156 plus my 3x equals 360. I'm going to minus my 156, which is going to give me 204. Then I'm going to divide by the 3, so x would have to be 68 here. Okay. Now, the next part that we need to know is about regular polygons. Regular polygons, it's a key word here. When we see the word regular, what we're learning is that is it a polygon where all of the sides are congruent and all of the angles are congruent. So if you kind of think, what would that look like? Well, a regular quadrilateral would be a square because all the sides are all the sides are congruent and all the angles are 90 degrees. So that's what you're dealing with. So here, if I have a single interior angle of a regular polygon, so what we simply do is we take the sum of the interior angles, which we know that to be 180 times n minus 2. That's the sum, and we know all the angles have to be the same. Then if we just divide it by the number of sides, which is also equal to the number of angles, then that will give us the single interior angle measurement. Okay, so let's try it here. So if you look over here, we have 1, 2, 3, 4, 5, and 6 sides. So that is a hexagon. So if we plug that in, we would have 180 times 6 minus 2 divided by 6. So that would give me 4. 4 times 180 is 720. Divided by 6 would tell me that each of these angles are going to equal 120 degrees. Because they are regular, so they all have to be equal to each other. Likewise, we have one for the exterior as well. Single exterior angles of a regular polygon, remember their sum is 360 divided by the total will give us the value of a single exterior angle of a regular polygon. It's got to be a regular. So if we kind of draw those in here real quick, if I just extend, here's 1 angle, 2 angles, 3 angles, 4, 5, and then 6. Okay, so if we look at that, we're literally just going to take and go 360 divided by 6 would give us each of these exterior angles is going to be 60 degrees. Now, I want you to notice one other little piece in this, and that is if you look at an exterior angle with its interior angle, you will notice that those two angles add up to 180 degrees. They have to be supplementary. They form a linear pair, so therefore they are going to be supplementary also. That might help you on some problems as you're working through looking at different things. Okay, so now let's go back and try, how do we work backwards in that formula? So if you notice on this problem, it says a regular polygon. Okay, so we know it's a regular, has one 24-degree exterior angle, and we want to know how many sides. So I know that my single exterior angle formula is 360 divided by the number of sides. So if we plug that in, we get 24 is equal to 360 divided by n. So I would multiply both sides by n. So that would get me 24n equals 360. At that point, we divide that by the 24. So n is equal to 15 sides. Okay. Likewise, we can go to the next one here. Again, I have a regular polygon. It has one 135-degree interior angle, and it wants to know how many sides. So again, we start off and we say, okay, a single interior angle is equal to 180 times n minus 2 divided by the number of sides, n. So we put in our number, so 135 is equal to 180 times n minus 2 divided by n. We multiply by n to both sides here. So that's going to give us 135n equals 180n because I'm going to distribute minus 360. At this point, I'm going to minus the 180n. And that's going to end up giving me a negative 45n equals a negative 360. I'm going to divide that by negative 45. And that's going to tell me that my polygon has 8 sides in it. And that's how we work through single interior and single exterior angles of a polygon, as well as the sum of the exteriors is always 360.